SolidWorks Simulation Lecture 4 2D Problems with Normal Force. Open a part file. Open a sketch on XY plane and draw a rectangle and place a dimension of 300 by 100 millimeters and draw a circle at the center of 40 millimeters in diameter. But now I'm not going to extrude it into a solid. Instead, I'll use a surface toolbar, a planar surface icon, to make into a plane, a 2D face. So now my CAD model is 2D model. It does not have a thickness, right? Now I'm going to proceed with CAE analysis. I'll open the static analysis study. It is a 3D study because I didn't check 2D simplification. Before we start, we proceed with other steps. Make sure that you have thickness defined. So we enter 4 millimeters as the thickness of this problem. And only after this we have completed the geometry part of the problem, because the CAD model has no thickness, so we have to define in CAE software. So now we have opened a study and completed the geometry. We have finished with the first step of CAE analysis. Now the second step is to choose the material. I'll choose alloy steel. The third step, place mesh, and I'll give it a finer mesh for 2D problems, and I'll hide the mesh. And then I'll apply boundary conditions on these two edges. These edges are actually surfaces of the boundary condition, since the model is 2D model. So now I'm going to apply a normal force on this circle. And this is the area of force application. And the direction, for the direction we can choose the area here to indicate the direction normal to this surface. So I'll give it a magnitude of 100 Newton. So now we can apply a normal force on a 2D model. Of course we can also apply in-plane loads, but it is not the point here, so I'm not going to apply any in-plane force here. So I'll check OK. So now I have completed the 4 steps for preprocessors, and the problem is fully defined. So I'll go ahead and run the software, and then this is the result. And let's look at displacement. We can also define the display into a 3D model, 3D display, render the shell thickness in 3D. So it will show the model in 3D, so it has a thickness, right? So for any software, most of the cases is that you have the option to display the result. Even the model is 2D, you have a way to display the result in 3D model. So this is how we can define a normal force in 2D models.